Hi, I'm John Vaslik. I'm the project superintendent on the Cornell CIS building project. It is roughly 135,000 square feet of offices and lab space that's going to be added to the Cornell Engineering and Computer Information School. I think the big part of this project is having an open mind and thinking outside the box, from labor to materials, delays in materials, thinking outside of the box, and a lot of times doing things outside of the normal sequence you may have done previously.
My name is Adam Walling. I'm a project manager here at the Cornell CIS project. Early on in design, the building was modeled, and the model was tied in with the building model for the Gates building. The Cornell Computing and Information Science building is tied into that building with a 3-story bridge, pedestrian bridge. Coordinating the survey of the two buildings, coordinating the models, making sure that everything lined up during construction was certainly a challenge. And accommodating the building movement was also a recently discovered challenge. The 3 buildings, the Gates building, the Link, and the CIS building, are all standalone and all move independently of one another. We had a surveyor on board from the beginning of this project. The surveyor was actually a part of the original design of the building. And they were here to help us lay out, make sure things were on grid and connected properly.
Every job anymore is basically complex with the time frames that we have. Some of the newer things, like the CLT, is getting used to finding out what the issues are with that, with the use of that, and overcoming it.
Cornell focuses on sustainable practices, and CLT is seen as a sustainable building material. I think CLT was chosen for this project because there is a big push for architects and engineers to be innovative and utilize new technologies.
You immediately start the research. If it's something that you have never used before, you start the research and find out what it is you need to do to make that successful. Got a traditional steel building with 3 of the 4 levels are CLT rather than traditional slab on metal deck or precast concrete plank.
Yeah, there's a lot of challenges with CLT that you don't typically think of at first. Safety, protecting and maintaining the CLT finish, because it's a product that goes in early on in the construction phase, and you do have to maintain that as it is a finished product. It required us to place steel angles very early on in the construction phase that needed to be set with precision in preparation for the metal panels, the fins, and the curtain wall systems.
Right from the very beginning, the loads had to be brought in exactly in order, okay? Which means they had to be reverse loaded, so they had to come in. The piece you're picking had to be the very next piece you put in. So there's a lot of coordination with the supplier with that. We basically devoted one person full-time taking pictures, documenting, and inspecting every single piece as it came off. Most of our panels they're all 7.5 inches thick, and a lot of the common ones were 8 foot wide by 41 feet long. And depending on the cutouts, every single piece was sent to an engineering firm to figure out the center of gravity and the proper location of the lifting lugs, so when they came off the truck, they'd be perfectly level and they'd be setting in place. The installation of the CLT itself was not, I don't believe, any more or less than the installation of a precast concrete plank. Once it's in place, though, you can get on it faster and start performing other work quicker than normal.
It is a big puzzle. We have weekly meetings set up with subcontractors, with the owner, with the architect. It's pretty cool to see all of the different components come together, to see the collaboration of our team and all of the hard work really begin to pay off.
I think this overall project, I think it went great. I do like the look of it. It's a unique building. I think it's something that Cornell and LeChase can be proud of.